In Learning Objective 3.0a, we're going to look at two different linear system examples and use any method that we want to solve. So in real life, I wouldn't necessarily say you have to solve by substitution or solve by linear combination. You would normally choose. And the graphical approach is not bad to get an estimation, but you have to be really careful that when you graph it, it's very precise. So let's use the graphing approach just to give us a gut idea of what the answer will be. But then we're going to use one of the algebra approaches to confirm it. Because on a test, if I say use any approach, it must be one of the two algebraic approaches. So let's actually do the algebra first on this one. If you look at it, we can either do substitution or linear combination. And I look at it and I think linear combination is going to be really slick, because if you look at it right now, if you were to add down, the y's would naturally cross off. You don't have to do anything. So definitely go ahead and use linear combination. So 2x and 1x is 3x. Again, plus y minus y is 0, and 13 and 5 is 18. To solve for x, divide by 3, so x is going to be 6. Okay, so I'm going to put x is equal to 6 back into one of the equations. I'm going to choose this one here. That would give me 2 times 6 plus y equals 13, which is 12 plus y equals 13. Therefore, y is 1. And I know that the final ordered pair answer, when I do graph these two lines, they're going to cross at the ordered pair 6, 1. Okay. Let's actually just use the algebra to confirm that, though. So this first one here, to graph it, I have to get it in y equals mx plus b format. So I have to get the y by itself, so that's pretty easy. I'm just going to subtract 2x from both sides. So that'll give me y equals, subtracting 2x would be negative 2x, and then plus 13. So I'm going to graph this, and I already know I'm going to have an issue with the graphing because my paper got cut off. It's not going to be the most precise, but I'm just going to do my best and see if I get close to landing at the intersection of 6, 1. The y-intercept is 13, so I'm going to go to 10, 11, 12, 13. From that point, I move a slope of negative 2 over 1, so I'm going to go down 2 to the right 1, down 2 to the right 1, and so forth. And I'm going to connect these dots after I graph the other one. So let's do the second equation here. I'm going to bring it down. To solve for y on this, I'm going to move the x first. So I'm going to subtract x. So we negative y equals, if I subtract x, it's negative x, then plus 5. I have to get rid of the negative 1 here, so I'm going to divide everything by negative 1, and I get the equation y equals x minus 5. So for this one, our y-intercept is negative 5. Our slope is up 1 over 1, up 1 over 1. And I'm going to connect those dots. Okay? And then I'm going to come down here and connect these dots. Okay. That's actually not a bad drawing. If I look at the intersection, it looks like it's at 7, 1 for mine. But again, I'm not too happy with the precision of this first graph because I had to continue making my own graph paper, and it wasn't that precise. We know if we did this maybe on a computer and we're more precise, what's going to happen. This will actually cross at 6, 1. This is why I always use the algebra to support it. Let's look at this one and just do an algebraic method. You can choose substitution or linear combination. If you chose linear combination, we could either get rid of the x's, make them both 1 and 8 and 1 and negative 8. So what I would probably do if I did that, I would multiply this by negative 4. That would make it a negative 8 and positive 8 down here. Or I could get rid of the y's. I could make them both 4s. This is already a negative 4, so I'd probably multiply this by a negative 4 itself to make it a positive 4. Okay. Or I could do substitution. And let's do substitution on this one just to do something different. For substitution, what variable would you solve for? The one that looks the easiest to solve for is the one without any numbers on it, is that y. So let's work on getting that y by itself. To do that, I'm going to subtract the 2x from both sides. So that would leave me with negative y equals 6 minus 2x. Let's get rid of this negative by dividing by negative 1. So that would be y equals 6 divided by negative 1 is negative 6. Negative 2 divided by negative 1 is positive 2x. Okay, so from the first equation, we got that y is this whole piece, and that came from this. So I must go to the second equation, where I see y, which is right there, is put this whole thing into there. Okay? So I'll be 8x minus 4 times, we have a negative 6 plus 2x equals 13. Now be careful on this one. I'm going to have to distribute a negative 4. So it'll be 8x. Negative 4 times negative 6 is positive 24. Negative 4 times positive 2x is negative 8x equals 13. When I do this, 8x minus 8x is 0. So I'm left with 24 equals 13. Wait a second. The variables just dropped out. It doesn't tell me what x is anymore. Remember, this is a special case. It means there's either no solution or many solutions. So when you look at this, is this a true statement? Does 24 equal 13? No, 24 equals 24 or 13 equals 13. It's false. So it means there is no solution to this graph of the system of equations. So what does that mean if you graph it? If you graph this, what you're going to see is these two lines are parallel. Well, I'm going to actually graph this right here because I already have it. The y-intercept is negative 6. The slope is up 2 over 1, up 2 over 1. It's that guy. Well, let me get this other one ready real quickly. I know I said I wasn't going to graph it, but let's do it. I'm going to solve this for y. This might get a little messy, but I'm going to take this guy here, solve it for y. I'm going to move the 8x over by subtracting. So just follow this. Keep this, and it'll be 13 minus 8x. And divide by negative 4. And what you're going to get is y equals 13 over negative 4 plus 2x. Well, notice this, you guys. They have the exact same slope. If they have the same slope, they're parallel to each other. Well, the only difference is this graph has a y-intercept. You know, what's 13 over negative 4? I'm going to type that in my calculator. It's about negative 3.25. So I'm going to go to the y-intercept of negative 3.25. From there, I already know it's going to be parallel to it because there's no solution. That's what it's going to look like.